Hello everyone. I hope you can hear me.
Hello, sir. Good evening, sir.
Yeah, good evening. So we'll start class as soon as possible. So I hope you can see the slide. So yeah, so I'll just uh, I was discussing earth pressure. So with this class, we'll be completing this earth pressure. In the next class, we'll be entering into shallow foundations. Okay. So I told what is earth pressure, what are the different types of earth pressures on the retaining wall. Uh, there are three types of retaining walls. Then I told you about the Mohr circle. What is the significance? Then so I drew the Mohr circle for three cases. For active, at rest, and passive. For active, we came to know sigma v will be more always. For passive, sigma h will be more. So that's how you know the equations. Sigma 1 equal to sigma 3 tan square alpha plus 2 c sin alpha, 2 c tan alpha, where sigma 1 is major, sigma 3 is minor. In active, sigma 1 is sigma v. In passive, sigma 3 is sigma h. So by using them, we have derived equations. Then I have given coefficient of active earth pressure Ka. Ka is given as this. Then Kp is coefficient of passive earth pressure. That it is just inverse of this, 1 plus sin phi by 1 minus sin phi. Then uh, so if it is cohesion-less soil, that means C equal to 0, then this term will be 0. Then you will be having only this one, okay, like this. So like that we have solved. Excuse me. Uh, then then we have solved one problem where there are two different layers, phi 1, phi 2, phi 2. So if there are two layers, how it is changing also I have told you about that. We have discussed just above, just above. You have to calculate using. So final diagram was like this. So from here to here like this, there is a sudden increment because there is a sudden change in Ka value. Then from here like this. So that's how we discussed. Then after that, how to calculate total force. It is just area of the diagram and the point of application of that. Suppose this is the area, you have to divide into known areas. Like you don't know the area formula of this total area. So you divide into one triangle, one rectangle, then another one triangle. Then you know the force from each area. You know the location of the force, it is just centroid. Then you can find out the moment about the bottom point, force into distance, F1 into L1 plus F2 into L1. So like that. So that's all about the previous classes. Now, so we will go with another problem. This is also very big problem and very interesting problem too. So, so I'll give you the diagram first. So now there are again two layers in this. Okay, now each layer height, this is 3 meters, this one is 2 meters. Okay, now for this layer 5C cohesion is C equal to 5 kilonewton per meter square, and phi value is 0, gamma sat is 20 kilonewton per meter cube. So there is a water table. Water table means it's completely saturated. So while calculating effective stresses, you have to take effective unit weight, that is gamma sat minus gamma w. So gamma w can be taken as 10 also. Let me check the question first. Yeah, gamma w is 10. So given that gamma w is 10 kilonewton per meter cube. See the units, don't forget the units. C has units of shear strength because we have learnt shear strength equation as C plus sigma tan phi, where C is, this is also in kilonewton per meter square because shear strength it is, then cohesion also should be in the same units, this is also should be in the same units, normal stress. This doesn't have units, that's how it is. Okay, so that's why now uh, phi 30 degrees for this layer, gamma sat for this layer is 18 kilonewton per meter cube, and for this there is no C value. Sorry, there is no C value. It's a sand. So top one is clay by because it has only uh, cohesion, whereas the friction angle is 0. For this C is 0. That means it is cohesionless soil. Okay, basically it's a sand. You can say basically it's a clay. Now you know the properties. Now you should find out um, what is the aim of this. Aim of this is total lateral earth force. Total lateral earth force. Force means area of the earth pressure diagram. That's it. Total area. Okay. This is the question. Now you have to find out. So let us solve this one by one. Okay. Let us say this is layer one, layer two. Let me. So for uh, layer one, what is the first step we do in this? We will find out the coefficient of earth pressures. Coefficient of earth pressure means Ka. Okay, we are talking about here coefficient of lateral active earth force. Okay, active earth force. That is the question. Okay, see for passive and active, sorry, at rest earth pressures, you go through the any material. Okay, I am just solving lateral earth forces, active earth forces. Okay, in this class. Now the concept is same. Wherever minus is there, you just have to put plus for the passive. Okay, that's the only difference. Give me just 30 seconds. I'll be back. Okay, so So now our aim is to find out active earth pressures, active earth force. So for that you need Ka value. Ka, you know the formula, 1 minus sine phi by 1 plus sine phi. Okay. For first layer, Ka1. Okay. What is the Ka1 value? 1 minus sine 0 by 1 plus sine 0. It's equal to 1. So Ka equal to 1. What about Ka2? 1 minus phi 1. Okay. 30. 1 plus sine 30. How much is it? Can somebody tell me how much is it?
Sir, point zero, 0.33.
0.3, right? 0.333. Okay. Now we have the two K values. Now we will enter into the vertical stresses. First, you need to find out sigma V dash. Then you have to multiply Ka to the sigma V dash. Then you might have to add 2c under root Ka, or you might have to deduct 2c root Ka. So what is the formula? We'll just write to remember that sigma H dash active earth pressure is, sorry, not a dash, it's not dash, sigma H is Ka multiplied by sigma V dash minus 2 into roots 2c under root Ka. You found out Ka now, you just have to find out effective vertical stresses, and also you know the C value for that layer. So now we will again draw that so that we will understand. Always in every, can I copy paste this? Yeah. Okay, now, okay. So now it's 3 meter. I'll just copy paste right now. That will be good. We need this diagram in every page, almost all. Okay. Okay. Now we are here. What shall we do first? We will divide into three parts. Sorry, we'll don't. We will give 3 points first. This is point one, point two, point three, because these are the three boundaries. So you, if you find out what is the value of sigma v here, sigma v here, then sigma v here, then you can draw the diagram because it is anyway linear in between that. So first, okay, this is top, at the top. At the top, what we have to find out first, sigma v, sigma v or v dash, and we will find out sigma v dash directly. Gamma effective, gamma effective means gamma saturated minus gamma w, that means gamma submerged. Also you can write gamma submerged multiplied by h. What is the h at the top? It is zero depth. Okay, from the top, so the value is sigma v dash is 0 there. Okay, now, um, What is sigma h? Sigma h is Ka sigma v dash minus 2 into root c under root Ka. We know what is the Ka value for this. This is 1. What is Ka value for this? Ka2, Ka1. This is 0.33. Okay, now Ka1 because it is in the first layer. Okay, this one at the top. How much? 1 multiplied by 0 minus 2 into how, what is the C value? C value is 5 for that. 5 into under root 1. So how much? Minus 10 kilonewton per meter square. So that I'll write as kPa. Okay, sigma h top. Now I found out what is the horizontal earth pressure at the top. That is done. Now what is the next step? What is next? Next is at 3 meter depth, right? At 3 meter depth. 3 meter depth means at this point. At this point, what are the sigma v dash, sigma h? What are those things? So first, let us calculate what is the sigma v dash there. What is the sigma v dash? Gamma sat has been given. Gamma sat is 20, I think. Yeah, gamma sat is 20 here. Gamma sat is 18 here. It's kilonewton per meter cube. Kilonewton per meter cube. So, what is the value at 3 meter for sigma v dash? You just have to gamma sat minus gamma w multiplied by h at the rate 3 meter. Okay, it's nothing but 20 minus 10 multiplied by 3. What is the value? Sigma v dash 10 into 3, 30 kPa. Okay, 0 kPa. This also stresses kilonewton. Now you have calculated what is sigma at this point 30 kPa. Then what we should calculate now? We should calculate sigma h. So just above, just below, at the 3 meter, just above. Just above means, just above means we will fall in the first layer. Just below means we will fall in the second layer. But at that 3 meter only, just above, just below, doesn't matter. Sigma v dash will be same. Okay, so just above we will talk about just above now. So what is the sigma h value? Ka1 just above, sigma v dash minus 2 into c into k. So why I am calculating 2 into c into under root? Because it is having cohesion. Okay, also here friction angle, some friction angle it has. What is it? 30. Okay, so it has clay above, uh, sand below. Better you write total formula. If c is 0, you can put c is 0. If you are getting something is 0, you can put. So total formula is better always. Okay, now Ka1 will be 1 multiplied by 30 minus 2 into 5 into under root 1. How much? 30. And one more thing, this is total horizontal earth pressure. I told you in the last class. So this is due to soil, but there is water table also here. Okay, from the top. If it is there, suppose here also we have to add water pressure, gamma multiplied by h, gamma w multiplied by h, 0. That's why it is 0 total. Why? In the vertical stresses we were talking about only effective. Okay, always we were neglecting water pressure. That's why we are deducting gamma sat minus gamma w. But here, why am I adding? I told you in the last class. So this part contributes effective horizontal earth pressure. That is fine because you are using effective vertical stresses, you have to get effective horizontal earth pressure. But here water is also there. Water will also give some pressure, whereas vertically water will not give any pressure on the soil particle. Okay. Instead, soil particles weight will decrease. That's why you will take gamma submerged of the soil. Whereas coming to the horizontal, see this retaining wall is completely stopping total soil and water from falling. So that means you are getting the pressure from the water also. So water pressure will not be multiplied by Ka, whereas vertical stress is multiplied by Ka, whereas water pressure will not be multiplied by Ka, because at any point H depth, water pressure will be same in every direction, maybe vertical, maybe horizontal. So you should not multiply anything for the pore water pressure. Pore water pressure will be equal at any point. So if at a particular point in every direction. Okay, that's how I forgot to write here. Okay, this you have to add gamma w into h. So here place gamma w is how much? 10. H is how much? 3 meter. So here 30 minus 2 into 5 into under root 1, it's 10, right? Then plus 10 into 3, 30, isn't it? Then what is the value? It should be 50. Is it? Am I right?
Yes, sir. 50.
Yeah. Okay. 50 kPa I will write. So I know above, just above what is the value. So I'll go to just below. So what now we have calculated it at 3 meter. Now just below again sigma h Ka 2. Now Ka2, because we are just below in the second layer now, multiplied by sigma v dash minus 2 root c under Ka2 this time plus gamma w into h. So at 3 meter, just above, just below, nothing changes other than Ka value. So what is the Ka value? 0.33 multiplied by sigma v dash is 30 minus 2 into, now just below, what is the C value? Just below, what is the C value?
Sir, 0.
0. You have to put 0. Okay. There are some things which change, of course. Friction angle, cohesion. Because of the friction angle, Ka value changed. Because of the cohesion, this will change. Okay. Okay. Now under root Ka will be under root 0.33 multiplied by 10 into 3. Sorry, plus. So can you tell me what is this? 0.333 into 30. I think, I hope it should be 10. Isn't it? Is it 10?
Yes, sir.
Yes.
10.
Minus, it should be 0 plus 10 into 3, 30. So how much? This time it is 40 kPa sigma h at 3 meter. So now I just want to draw that. Okay. I just want to draw till 30 meters. How does it look? Okay. Okay. Now I'll just draw the diagram of sigma h. So what is the sigma h value at the top? At the top it is minus 10, right? So minus 10. If it is 0, this is minus 10. And at 3 meter just depth, just above, it is 50 kPa. 50 kPa. If it is 0 line, okay. plus 50. This is 50. So you just have to join. That's it. This is one thing. Next, immediately what happened at the same depth just below 40 kPa. So you should go little back. This is 40. Now from here, definitely it will increase. How much we don't know. Okay, that we will calculate. So I'm going back again. Okay, now what should we calculate? We should calculate at the bottom now. Third point at bottom. At bottom, sigma h Ka2 because bottom is in the second layer. Ka2 multiplied by sigma v dash at that place minus 2c root Ka because this is the total formula plus gamma w into h. So now just tell me what is the sigma h value. Ka2 is 0.33 multiplied by sigma v dash we have found out initially only. Sigma v dash. So we did not. I think we are finding only at respective depths. Okay. Now for that I need to calculate first sigma v dash at the bottom. Sigma v dash is generally how do we calculate? It's gamma summation of sigma equal to n number of layers. Okay. Gamma effective of that particular layer multiplied by h of that layer. Okay. If there are two layers, gamma 1 h1 plus gamma 2 h2. Okay. Now gamma effective means gamma submerged. If it is gamma bulk, gamma bulk. If it is gamma saturated water table, then it will become gamma submerged. So now tell me how to calculate at the bottom. At the bottom means up to this point. Gamma effective 20 minus 10 multiplied by h is 3 meter plus gamma effective of this 18 minus 10 multiplied by what is the height 2. That's it, na? Can you tell me what is the value? It should be 30 plus
46.
46 kPa. Okay, we know the sigma v value at the bottom. Just put that sigma v dash is 46 minus 2 into what is the c value in the second because bottom is at the second layer. C value is 0 now. Okay, Ka is 0.333 plus gamma w 10 multiplied by h is 5 now, right? What is the height at the bottom? Total height. You have to calculate total. Okay, now at the bottom, just tell me what is the value. It is 65.
65.33.
Okay, I got 318. Anyway, no issues. Total horizontal earth pressure is this much. Now you got the earth pressures at every depth, isn't it? Okay. Now I'll just draw the diagram first. So already I have drawn off in the previous slide. Okay. Here up to here we got 40. What is the bottom? 65.318. Okay. I'll just copy paste this. That will be better. This is not okay. No? Now you got 40, and what is the previous value? 65.318. So 65.318. So this is the earth pressure diagram, sigma H diagram, sigma H diagram, right? So what else can we do now here? You have to find out total force in the horizontal direction. How will you do? See, this is the negative diagram. This is the positive diagram, right? You can calculate effective force. That means you have to calculate force, this force. So this force, then you can deduct this much force from this positive force. That's it. It's like summation. Suppose sometimes people may ask, you can neglect the tension zone. So what is tension? What is compression? I'll tell you now here. See, we were discussing the earth pressures were in which direction. Earth pressures will be in the towards the wall. So they will push the wall. They will push the wall. That is the pressure which is coming. But so if you see up to here, it is positive. That means the wall is pushed. But at this place, at the top place, if you see, that place is pushed in this direction. Okay, that's why what will happen, see, that means it is not pushed really, ideally it's not like that, it is pushing in this way. It's like that. If you see the, this is the wall, let us say. Okay, this is the wall. Now there is a clay or something behind. What happens now? To push this wall, there should be contact between this earth material and this. So it is pushing. So what is happening, this particular soil until this depth, this soil is not pushing it, it is pulling the, it is pulling the retaining wall, pulling towards its own. That means it is tension. It's a tension force on the wall, you can say. Because of that, what happens, wall will not move because of this small force. But at the end, what can happen is this, because of that force, at one point there can be a crack. So now this is the wall. Okay, this is the wall. Okay, this is the wall. Now there is a soil, so there can be a crack. There can be a crack like this, because like this, because this much of soil is in the tension. That soil has applied tension force on the wall. As anyway wall cannot move with that small force, wall will be stable. It will be detaching from the wall because of the tension force. That crack is called as tension crack. Tension crack. Okay, so now you can just think, uh, okay, let me complete this first. Okay, suppose if it is detaching, now there is no tension force on the wall because it is detached. Before detaching, it was applying this much negative force on the wall. Before detaching, it can apply only before detaching. Once it is detached, that means this much force is released from the wall. So people may ask you, before forming tension crack or after forming tension crack. Before and after forming tension crack. If before forming tension crack, what is the earth force means, you have to take all the forces because it is still not formed. That means this much force is applied on this. Okay, if it is after formation of tension crack, you have to neglect this because this much force is not applied now. So only this positive force is applied. So that is the, you have to neglect that tension completely. So neglecting Tension zone, this is called tension zone. Neglecting zone, nothing but after formation of crack. Okay. So now in general, I can say that, so what is the uh, mm, safer side to design the wall, if I ask? So how do you design the wall? You will design the wall by taking the force, how much maximum force applied from the uh, not a maximum, means the force at the failure. What is the force which is coming from the soil? So safer side means what? You try to be always on higher side of the force. You will design for that higher force, then you will you will be on safer side. Suppose if you don't neglect while calculating the force, this you are not neglecting this, that means effective force will be less. Suppose this positive force is 100 kilonewton, let us say, this is not this is a rough value, positive, and negative is coming 10, minus 10 kilonewton, let us say. So what is the effective? 100 minus 10, 90 kilonewton is the effective force on the wall, right? Now if you give effective force, if you consider this tension zone, then you will be on the uh, not you are actually on the conservative side, where you will be on unsafe side. Suppose if I say, after formation of the crack, what is the net force? After formation you will neglect this, you will have only 100, you will not deduct this much 10 after formation of the crack. So after formation of the crack only is the maximum force, which by using which people design this. Okay, that's how. Now we have got the pressure diagram, right? Now what shall we do? We have to uh, find out the force, total force. But before that, I just want to know how much, what is the depth. So I will just again redraw this one. So minus 10, okay, plus 50, okay, then this is 40, some 65.318, I think. Okay, this is the pressure diagram. And total height is 3. Can somebody tell me at least what is the concept, how to find out this? Let us say this is x. Somebody tell me. Minus 10, but if you just roughly take it as this much, this side it is 10, this side it is 50. Okay, now this is x and this is 3. So then what is this? 3 minus x from here. Okay, now what can I do here? How to find out x?
A similar triangle.
Similar triangles. So can you tell me what can I write for similar triangle? Tell me.
X by 3 minus x equal to 10 by 50.
X by 3 minus x equal to,
10 by 50.
okay, let us see. Yeah, yeah, I think generally what do we do? 10 by x also, yeah, I think you 50 by 3 minus x. Is it correct? Yeah, you're right. So can you calculate and tell me what is the x?
X equal to 1 by 2.
Yeah, correct. X equal to 1 by 2. That means 0.5 meter, right? This is 0.5 meter. So that means this is 2.5 meter. So now you understood this is 2.5 meter and this is zero point 0.5 and this is 2. Okay. Now how many triangles we can form to find out the force? Force is nothing but what? Here area of earth pressure diagram. This is the earth pressure diagram. Force equal to area of that. So how many areas? Let us say this is 1, this is 2, then I can, this is 3, this is 4, right? Because I these are the known formulas for me. This is rectangle. Okay, what is this? This is 40 and this is 2. This is 50 and this is 2.5. Then this is another triangle 10 and zero point 0.5. Okay, like this. So can somebody tell me, so we found out what is the height of the tension crack. This is nothing but, this x is nothing but, what is that called? Depth of tension crack, you can say. Depth of tension crack. Okay, that is how you will calculate. And another method also I will tell you how to calculate. But now you can tell me what is the first. I'll ask you positive force. Positive force, then negative force. For positive force, what are the things, what should we do? Force is nothing but area of the diagrams. Area of 2 plus area 3 plus area 4. So area 2 is formula half into 2.5 height into base is 50. What is the area 3? Area 3 is 40 into 2 plus area 4 half into height 2 into base 65.3, not 3, sorry, 65.318 minus 40, right? Only this much. At least can you tell me by using calci? You just tell me this.
Sir, 167.83.
So 167.83 kilonewton per meter cube. This is the total force. Okay, active force. Now this is what? This is after tension crack formed, or after neglecting the tension zone. This is what the force. Okay, if you, that is the uh, uh, force for the design. If somebody asks, by default you should calculate after formation of the tension crack. If they don't mention, if they mention, then you can deduct this much area. How to deduct? Minus half into 10 into height 0.5, right? 10 by 4, so 2.5. You just have to deduct 2.5 from it. So it doesn't matter, actually it's not much force, isn't it? Half into 10 into zero point 0.5, how much? It's 2.5, right? So it will become 165.23. That's it. So there is nothing, but this is the final answer. 167.83 kilonewton per meter cube. So this is how you will be calculating the earth forces. Okay. Now I told you another method how to calculate this depth of the tension crack. Depth of tension crack. So now one concept we will just learn from. Okay. crack forms like this. Okay, okay, fine. So this is the soil, let us say. So I have drawn the, now tension crack appears only in the active earth pressure, because in the active earth pressure sigma h will be Ka sigma v dash minus 2c root K. For some time we think that there is no water table. Okay, there is no water table means gamma wh is not there. Now what is the diagram for this, what we draw? At the top, of course, this is 0 at the top. Sigma v is 0 because it is gamma into h is 0. So obviously in active earth pressure, you have to get minus 2c root Ka at the top. Okay, if this is the 0 line, you will get minus 2c root Ka at the top. So after at some depth, it will become positive because this value is more than this. So finally it will be positive at some depth. Let us say at this depth. So it is some positive value. Then you will connect them. Okay. You will connect them. But if you tell me what is this line equation? This line equation is nothing but sigma h equal to Ka sigma v dash under root Ka. Because you are calculating and you are putting here. You are calculating and you are putting the value here at some depth. At another depth, you are calculating this and you are putting that. So it's nothing but this total points. It's a line. This line is nothing but this equation. So wherever it is becoming 0, till there, it's a tension. From there, it is compression. So now, if you see from here, it is forming the tension crack. Okay, if it wants to form, it will form till till that depth after detaching from the wall. So now if somebody asks what is the depth of tension crack, depth of tension crack, what can you do? It's easy, you just have to equate this equation to the 0. That's it. So wherever this equation becomes 0, that is the tension crack. How? So I will make, let us make that equation to 0. Okay, sigma v dash at that depth, okay, at that particular depth, minus 2 root c Ka equal to, it is becoming 0 at that depth. So now Ka, so gamma, okay, gamma dash or gamma bulk, whatever it is, okay. Then z, I'm talking about this. Sorry, just a minute. Gamma multiplied by z minus 2c root Ka. Here, what is the variable in this total equation? Ka is constant, C is constant, K is constant, gamma is also constant. Only Z is varying. As the Z is progressing, then you will get different earth pressures. So at one particular Z, it is becoming 0. This total value is becoming 0. So now I just equated to that 0. Let us calculate. K gamma multiplied by Z equal to 2c root K. Right? I just took this totally outside. Okay, now Ka gamma Z equal to 2c root Ka. Then what is the Z? That is what? 2c root Ka divided by gamma Ka. It's nothing but 2c multiplied divided by gamma root Ka. So therefore, depth of tension crack is nothing but 2c gamma under root Ka. Right? Under root Ka. Now for pure clays, for pure clay, pure clay, C will be there some value, but phi will be 0. If phi is 0, 1 minus sine phi by sine phi, which is equal to Ka. If sine phi is 0, sine phi is 0, 1 by, okay, then Ka equal to 1 for pure case. Okay, C not equal to 0, phi equal. For pure case, K equal to 1. In that case, what will it become? For pure case, for class Z, depth of tension crack is just 2c by gamma. That gamma is effective. You should remember that. It's not just gamma saturated or something. Okay, now this is one concept. From here we can derive this. Where were we? Not here. So I calculated this using this method, no, we by using triangle method, right? So how do you calculate now? You will just where is the top? This is in the top layer. So top layer formula will go in the top layer. So in the top layer till 3 meters, what is the equation? Okay, you just have to take 50 wala equation because it is decreasing later. But in that layer, you can consider only these two triangles. Okay, first it is going from minus 10 to 50. So you have to use the equation which is giving the 50. So which is giving 50? This is giving 50. This. Okay, this equation. This equation only gave you 0, sorry, minus 10 at the top. This equation only gave 50 at the bottom of that layer. So now using this same equation, if you see Ka1 sigma V is changing, that we know. 2c is same, Ka is same, H will change anyway from the top to bottom, gamma W is, so everything is same other than the Z. So this is the common equation for that layer. That common equation is becoming 0 in between minus 10 to 50 in that layer. So this common equation should be, you just make it to 0. Ka1 sigma V dash is nothing but gamma effective multiplied by Z minus 2 into 5 into under root Ka, again 1 it is, plus gamma W is nothing but 10, H is again Z equal to 0. That Z is the only unknown. You can calculate the Z using this equation now. Okay, that is one thing. So another thing I just want to tell. So now if you see again, you see, so what will I do? Tension crack is forming, then another something like this. So there is a retaining wall. There is a retaining wall. So what I'll do, first I'll draw the diagram. Oh, sorry, it's going. I'm not getting the directions in this pad. Okay, fine, that's good. Okay, so there is some negative pressure, there is some positive pressure. Okay, as you go down. Okay, but suppose if this the tension depth of tension crack, let us say it is ZC, ZC. Some this is something else. Now, if I draw another ZC down, okay, this is positive, this is negative. Can somebody tell me what is the net force from the clay towards the wall up to here? What is the net force above this line?
0.
0, because I am again taking up to another ZC. So both are not similar triangles, both are equal triangles. Now, so up from this up to this depth, net force is 0. Okay, up to this depth, it's not that, it's at that depth, net force is 0. Before that, it is still tension. Okay, till here only tension, crack will form. After that, crack will not form, but net force will be tension because some compressive, then come another net force will be tension. So up to this depth, net force will be in the tension. Then at this depth, total force is 0 from this depth. So the net force will be the, so if you calculate only area of this, you will get only the net, okay, before formation of the crack. If it is after formation of the crack, then you will have to neglect this after formation of the crease. Okay, so people actually to again correct my sentences which I've used initially, it's not after formation of the crack this much force will come. After formation of crack, after formation of crack, this much force will be coming. Before formation of the crack, the net force will be this minus this. Yeah, that is correct. I didn't say anything. So after formation of the crack, only the force, um, final force, that is only this. So before formation, the effective will be only this much, right? Because total is 100. I have given example like this total is 100, then this is 10. So 100 minus 10 means this is also 10. So this is 90, right? Now you must have understood. 10, 10, 90 minus 10 plus 10 gets cancelled, then you will be left with only 90. So anyway, so I was right anyway. So now the interesting point in this, so as I told, you have told me above this depth, if this is ZC tension crack, another ZC down, so this is negative, this is positive, total effective force is 0. So if effective force from the soil is 0, that means the soil is not giving any force, then you can remove that retaining wall till the depth. So retaining wall is for what? Retaining wall, what is the use of retaining wall? You are keeping the soil in place. If you remove the retaining wall, soil will fall. But this portion, this portion, soil will not fall because soil is not giving the force first of all till this depth, right? So you can remove, you can just remove the wall. Means after formation of the crack, I'm telling. I'm just telling um, um, idealistically, if the tension crack is formed, you can just demolish this much wall, but nobody will demolish, nobody should demolish. But I'm just telling, why I'm telling this, anyway force effective is 0. Now this length or this much depth which is not requiring any support is called unsupported length or unsupported depth. Okay, that is also called as critical height. This critical height or depth of unsupported vertical trench, depth of unsupported length. Okay, it is nothing but how much? 2 into ZC. You know how to calculate ZC, okay, by equating the equation to 0. After calculating ZC, you have to find out critical height like this. You just multiply by 2, then you will get the height of unsupported length. So now if if going to the ground in the clay grounds, people, what do people try to dig? Okay, when people try to dig, generally it is still intact. You are digging, but it is not falling. Have you ever thought why is it not falling? Because of the cohesion, because of that minus 2 root c k. It's the force is not in this direction, force is in this direction. Here also force is in this direction. And what is this height? Up to where you can go? Up to this height. Up to this height, 2 into ZC, you can dig without fall of this. Suppose you are going too much down. If that is, that can fall. then the net height of, if height is greater than hc, it will fall. If it height is less than hc, it will not fall, less than or equal to hc. So this is all about the critical height, depth of unsupported length. If somebody asks what is the unsupported length, you should calculate zc and multiply it by 2. So this is all about today's class. So is there any doubt? So we can close the session now.
Sir, I have a doubt.
Yeah, tell me.
Sir, at just below the meeting layer, we take
Okay,
Ka2. We take Ka2.
just below the first layer.
Sir, below the first layer,
Hmm.
we take Ka2.
Okay,
Sir, what Ka2 signifies in practical basis?
pressure is reducing. Horizontal pressure is reducing at that particular depth.
Sir, sir, but Ka2 is like a property of soil, na?
Property of soil, yes.
Yes, sir.
Yeah,
Sir,
it's a property of soil. That is the property which is giving a horizontal pressure. Okay, if the property itself is changing, then pressure will reduce. That's how
okay,
it
sir.
is. Yeah,
Okay, yes, sir. Got it.
yeah. So can I close the session then?
Yes, sir.
Okay, okay then. So let's meet in the next class.